Right, guys, let's look at rounding off when we look at specific formulas, and watch out for this. This is a very important lesson. Let's have a look. Let's go to the formula for degrees again. For temperature, the formula for converting degrees to Fahrenheit, converting degrees to Fahrenheit to degrees Celsius is given by this formula. What is 0 degrees Fahrenheit in degrees Celsius rounded off to the nearest degree? Okay, well, if we plug in 0 there, what happens is we get minus 32, and it comes to this thing. Now, in this situation, we can round down. We get to minus 17 degrees Celsius. Now, what's important about this, guys, is that they just said, you know, you've got 0 degrees Fahrenheit. You want to convert it to degrees Celsius. It comes to minus 17 degrees Celsius. Okay, and it was 17,2. We can round down. It's not like the previous lesson where we had the material, where we had to, although it was 7,35, we rounded to, we rounded up rather than down. It was because of the situation. This doesn't really matter. We just want to know roughly what it is. Okay, now, very important, if we have a look at another one, a person's body mass index can be calculated using the formula BMI, body mass index, is mass divided by height squared, where M is the mass of the person in kilograms and H is the height of the person in meters. You'll find in South Africa sometimes, and even in countries like America, where the body mass index is a little bit not too lacquer because people are often eating the wrong foods, and what happens is that their body mass index goes out of proportion. You want to try and aim for a normal thing by eating well and eating healthily. Okay, so let's have a look. Calculate Borgo's BMI accurate to 1 decimal place. This is important. If he weighs 98 kilograms and is 2,2 meters tall. Let's see what his body mass index is. Okay, now watch this. Okay, well, there's the formula for BMI. 98 divided by 2,28 squared. 2,2 squared. Okay, if we do this, let's check in the calculator. We're going to go to a calculator, and we've got, open the fraction button, we've got 98 divided by 2.2 squared. Let's go 2.2 all squared. Okay, that's nicely in the calculator. Equals, okay, 240 over 2450 divided by 121. And if we push ST, we get 20,24793 going on like that. Okay, let's have a look at what the slide says. Okay, 20,247. Now, what we've got to do is we've got to round off to the right number of decimals, which is 1. And in this case, we go like this, which is 20,2. Notice, go to 2, 1 decimal there. Okay, and what do we do there? We can easily see that we go to the 2 there. And what does it do? It's going to give us 2,20,2. Remember, the 4 there is not going to affect the 2 if you're rounding off to 1 decimal place there. Okay, very cool situation this. Okay, so watch out there. That 2 is not going to be affected. 20,2, that's the body mass index. Okay, now the next example I want you to watch very carefully. Money. Okay, if you look at this example, money, unless specified, is always rounded off to 2 decimals. So if you get a decimal, 60,73, blah, 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 you round it off to 2 decimal places with money. Okay. Now, the next important thing is very important. Only round off your final answer. We call in the world of maths a thing called an error margin. People, if you round off too soon, you're going to land up with errors following through and you get a very inaccurate answer. Now, let's look at a typical example of this. Here's an example quickly. It says the distance in kilometers moved by an object after t seconds is given by the formula distance is 0,13 multiplied by the square root of t. Bit of physics here. Okay, so the object's moving. Now, very important. Let's carry on. The reduction in its mass is given by the formula mass is 4 divided by 1 minus d. Calculate its mass after 26 seconds. Remember, this object is probably moving through the universe, and what's going to happen is as it's moving, it's reducing its mass. So let's see what happens if we look at this. Now, we've got to calculate its mass after 26 seconds. Now, have a look here. Well, there's our formula for d. Okay, 0,13 root t, and there's our formula for mass. Now, what we want to do is we're given t is equal to 26 seconds. Okay, t equals 26. Now, if you plug it in there, let's see what we get. Let's go to the calculator quickly. We've got 0.13, and we're multiplying by the square root of 26. It gives you this decimal there, 0.66 going on. Now, watch this. Keep the D as this full decimal. If we go to the slide again, keep it as that. Now, if we move on, the D is 0.6, the mass is this. Now, if you put into the calculator 4 over 1 minus this whole thing and you work it out, you get 11.86. That's the mass of the object. But now, if you had to round off to 0.7 and put it in, notice what's going to happen here is you're going to land up getting 1 minus 0.7, okay, which is 13.3, which is way off what you're doing. So the moral of the story, guys, is work to maximum accuracy. Very, very important. Well, guys, that was great being with you. We'll see you again for another exciting episode in Matrix Uploaded for Maths Literacy. See you around.